Hello everyone, good evening. So here we shall start from question number 15 onwards. So here it is given that ABCD is a parallelogram. ABCD is a parallelogram in which P is the midpoint of DC. P is the midpoint of DC, and Q is a point. Q is a point on AC, such that CQ equals to 1 by 4 AC. CQ equals to 1 by 4 AC, and also PQ when produced, PQ produced meets BC at R. We have to prove that R is the midpoint of BC. R is the midpoint of BC. So how to prove it? We can see that OA equals to OC and OB equals to OD. OB equals to OD. Since why? Since in a parallelogram the diagonals bisect each other. Since in a parallelogram the diagonals will bisect each other. So I can say that OA equals to OC equals to half of AC. And CQ equals to 1 by 4 AC, which is given. So hence I can say that CQ is equal to half of AC, which is equal to half of OC. CQ is equal to half of AC. So hence we can say that Q is the midpoint of OC. Q is the midpoint. Q is the midpoint of OC. And P is told it is the midpoint of DC. So now in triangle COD, P is the midpoint of CD. P is the midpoint of CD, which is given. And Q is the midpoint of OC. Q is the midpoint of OC, which is proved above. So therefore, we can say that PQ is parallel to DO. PQ is parallel to DO. By using the midpoint theorem. So we can also say that PR will be parallel to DB. PR will be parallel to DB in triangle CDB. So now we can see that in triangle COB, Q is the midpoint of CO. Q is the midpoint of CO, which is proved above. And QR is parallel to OB. QR will be parallel to OB. Since why this is also proved above. Since PR is parallel to DB. Simply here we can say proved above as PR is parallel to DB. So therefore we can say that R is the midpoint. R should be the midpoint of CB. R is the midpoint of CB or BC. R is the midpoint of BC by using the converse of midpoint here. By using the converse of midpoint here. So hence proved. Then here it is told, here it is given that AD is the median. AD is a median of triangle ABC, and E is the midpoint of AD. E is the midpoint of AD. Also, BC, also BE produced, BE produced meets AC at F, AC at F, and then we have to prove that AF equals to 1/3 of AC. AF equals to 1/3 of AC. So here we need one construction. Construction is required. So here we will write that through the point D, a line segment is drawn, which is parallel to BE, which intersects AC, at P. Intersects AC at P. Now we will write the proof. The proof will be, we say that D is the midpoint. D is the midpoint of BC in triangle ABC. Since it is given that AD is the median on the side BC, which is given. So hence D should be the midpoint of AC of BC, and DP is parallel to BF. DP is parallel to BE, or I can say DP is parallel to BF. It is according to the construction. So now you can see that in triangle CBF, DP is parallel to BF, and D is the midpoint of BC. D is the midpoint of BC. So therefore, I can say that P is the midpoint. P is the midpoint. P should be the midpoint of CF. P should be the midpoint of CF. should be the midpoint of CF. Uh, by using the converse of midpoint theorem. By using the converse of midpoint theorem. So therefore we can say that CP is equal to PF. CP is equal to PF, which is equal to half of CF. Also, you can see that in triangle ADP, also in triangle ADP, E is the midpoint of AD. E is the midpoint of AD, which is given. Is the midpoint of AD, which is given, and EF is parallel to DP. This way we have, which is according to the construction, that DP is parallel to PF. So hence EF is parallel to DP also, which is according to the construction. According to construction. So we can say that F should be the midpoint of AP. So F is the midpoint. F is the midpoint of AP. Is by using the converse of midpoint theorem. By using the converse of midpoint theorem. So we can say that AF is equal to PF equal to half of AP. AF equals to PF, which is equal to half of AP. So therefore, we can see that AF is equal to PF is equal to CP. AF is equal to PF is equal to CP. And also AF plus PF plus CP. Yeah, AF plus PF plus CP. That is equal to AC. That is equal to AC. So hence, we can say that PAF that is equal to AC, which means that AF is equal to 1/3 of AC. So hence proved. Then here is given that and here it is given that ABCD and PQRC are rectangles. ABCD and PQRC are rectangles where Q is the midpoint of AC. So Q is the midpoint of AC. And then we have to prove that first is DP equals to PC. Second is ER is equal to half of AC. Q is the midpoint of AC. So now you have to, so the proof is that you can see that AD is parallel to BC, is parallel to PQ. Hence, we can say that the opposite sides of a rectangle are parallel. Opposite sides of a rectangle are parallel to each other. Parallel to each other. And also, CD is parallel to AB, which is parallel to QR. The reason is same, since the opposite sides of a rectangle are parallel to each other. Parallel. Now here I can say that in triangle ABC, Q is the midpoint of AC. Q is the midpoint Q is the midpoint of AC. And Q is the midpoint of AC. The reason is that it is given. And QR is parallel to AB, since it is proved above. So therefore I can say R is the midpoint of CB. R is the midpoint of CB. B actually. R is the midpoint of CB. Just the midpoint of CB by using the converse of midpoint theorem. By using the converse of midpoint theorem. What is the midpoint of CB by using the converse of midpoint theorem? Also, I can say that in triangle ADC, PQ is parallel to AD, which is proved earlier or proved above. And Q is the midpoint of AC. Q is the midpoint of AC, which is given. So I can say that P is the midpoint of DC. So P is the midpoint of DC. Here actually we need one construction. Construction is that the diagonals that is PR and BD are drawn. The diagonals and the PR and BD, we have PR, it is this one, and BD also that we have to draw. So now here P is the midpoint of PC by using the converse of midpoint theorem. By using the converse of midpoint theorem. Now we can see now in triangle CBD, P and R. P and R are the midpoints. P and R are the midpoints of CD and CB. P and R are the midpoints of CD and CB, respectively. Are the midpoints of CD and CB, respectively. Since it is proved above. So therefore, I can say that PR is parallel to BD and PR equals to half of BD by using the midpoint theorem. Using midpoint theorem. So here we have found that P is the midpoint of DC. Therefore, I can say DP is equal to PC. DP is equal to PC, which is equal to half of DC. So hence the first part is proof part 1. And here also PR is equal to half of BD we have proved by using the midpoint theorem. And also we can say that KC equals to BD. KC equals to BD since why? Since the diagonals in a rectangle are equal. If the diagonals in a rectangle are equal. So hence we can say that PR is equal to half of AC also. So hence proof part 2. The second part has been proved.